What's up, everybody? Welcome back to 8th grade science. In this video, we are looking at TEK 8.5b. So if you're here, you're trying to review the idea that protons determine atomic identity and that electrons, valence electrons, determine element reactivity. We have one poster up in the room right now that can help you with this, and also this graphic organizer is meant to help you, and then I'm going to preview your activity that you're going to do right here. Because as soon as you finish this video, you have an activity that you're going to complete with your table groups. First things, we're going to make a couple notes. Protons, it says right here, determine an element's identity. This organizer is split in half along this dotted line, and it's kind of both using the same image. So protons, and I want you to square the definition of protons, or not the definition, but the function. They determine an element's identity. It is like, come to the upper right corner of your page, right? Protons equal driver's license. Oops, misspelled it. The protons tell you what the element is. Just like your driver's license, when you get one, or if you get one, tells people who you are. It's official proof of identification. That's what protons are. If it's 3 protons, you can prove it's lithium. If it's 6 protons, you can prove it's carbon. If it's 10 protons, you can prove it's neon. So on and so forth for every single element. Okay. Another key thing we need to write is you get your number of protons from the atomic number. And then I want you to draw an arrow to it. This is the atomic mass. The bottom decimal number is the atomic mass. The atomic number is the whole number. It is the number of protons. It is the driver's license of the atom. Okay? Then, in contrast, we have valence electrons. Valence electrons determine an element's chemical properties. The main chemical property, I want you to circle chemical properties and then come right down here by this corner and write the word reactivity. The main thing we learn from the number of protons is how reactive an atom is. The number of electrons is how reactive an atom is. The valence electrons, that means those on the outer, I want you to put in parentheses after the word valence, the word outer. The ones on the outer shell, they determine how reactive something is. Come to the other corner of your organizer. If something has 1 valence electron, it's reactive. If something has 7 valence electrons, it's reactive. If something has 8 valence electrons, it's unreactive. The video is going to pause. I'm going to ask you why are valence electrons, 8 of them, unreactive. Video's going to pause. Give it a good shot. All right, now that you've typed your answer, we're going to go over why 8 valence electrons make something unreactive. Remember, 8 valence electrons fills the outer shell. The outer shell is a van. There are 8 seats in the van. There are 8 electrons in the valence shell. If you are in group 18, you are full. You're not willing to react. 1 and 7, when they combine, I want y'all to write this, they make 8 electrons. That means they're trying so hard to get the van full that they combine. They're very reactive together. 1 valence electron, like we have here, super reactive with elements that have 7. Okay? That's the general idea. Now what we're going to do, What's up, everybody? This is the first time I'm trying to recut a video, so I made an error in this part of the video, and I'm going to put this at the back half of another video I recorded. So if the transition sounded weird, that's why I did. This is the first time I've had to edit, but that's all right. We are getting through it. So I'm going to do this section right here for us. Remember, we are looking at the activity that's going to come after you complete this this video. You're going to be looking at these atom cards and these atom spaces. So what I did, I noticed atom card number 5. And I want to figure out what atom I was looking at. I needed to match it to one of these colored cards. So the way I did that was I counted the number of total electrons. Total E minus, I want you to write with me. And this atom is equal to 6. That is also equal to the atomic number. atomic number tells us in a neutral atom the number of protons and the number of electrons. So I know my atomic number is 6. Then I would have searched my atom cards, looking for something with an atomic number in the upper left of 6. I found it, and that's our atomic number. That means atom number 5 is, and you would fill in the box, carbon. You can actually do this on your note sheet, and also if you want to on your worksheet, because number 5 is carbon. This is literally from your activity. How many protons and valence electrons? Every time we see the word valence, we cross it out, we replace it with outer. How many protons and valence electrons does this atom have? Well, its atomic number, 6. So we're putting 6 there. And then its number of valence electrons. Remember, the word valence means outer. So the number of valence electrons here, I'm going to circle them. 1, 2, 3, 4. Number of valence electrons is 4. All you do is count the outer layer. In some cases, depending on the way this looks, you might be able to tell that the valence electrons in these cards are darker because they're red versus yellow, but that might not print out the best. So just count the exterior layer. All right. Then what we have up next is determining whether the atom is reactive or stable. We're quickly going to take notes on that before we start reactivity. We're looking for stability versus reactivity. I want you to write stable, right? Does not react. We're going to talk about why things don't react. Reactive tends to react. So if something's stable, it does not react. If something is reactive, it tends to react. It tends to do something when mixed with other substances. All this depends on is the number of valence electrons, right? We only know things are stable when they have full valence shells. That can mean, come here with me, 8 in outer or 2 in one case. So if something is stable, it means it has 8 valence electrons. Except for if something has only 2. There's one case where an element with 2 valence electrons is stable. That's helium, because you will see in the picture, its outer shell is the very first shell. It's that motorcycle, so there's only 2. That's the one exception. Otherwise, if there are 8 valence electrons, it's stable. If it is not stable, that means it has 1, 2, 3, 4, 5, 6, or 7 valence electrons. So when you count, all you have to do is convert this number. If that number is 8, or if it's 2 with helium, it's stable. If it's anything else, it's reactive. In this case, it is 4. It's anything else, it's reactive. All right? Give this a shot now in your activity.